Today's topic is the prisoner's dilemma and the strict dominant solution concept. I cover this in lesson 1.1 of my textbook. You can learn more about that by clicking on the video description. In any case, here's the situation. Two suspects are arrested. The police think that they are trying to rob a store, but the cops only have the evidence to prove that the suspects were trespassing. Thus, to charge the convicts with the greater crime, the police are going to need one of the criminals to rat out the other. And the way the police are going to elicit a confession is by throwing them into the prisoner's dilemma, which looks like this. Each of the convicts is going to be privately sequestered in an interrogation room and offered the following deal. If no one confesses to the robbery, the police are only going to be able to charge the prisoners with trespassing, and the punishment for that is 1 month in jail apiece. But if one confesses and the other one doesn't, the police will be leaning on the rat, thanking him for his confession, and severely punish the quiet one. That's going to be 12 months in jail for the one who kept quiet, and the one who ratted out the other guy is going to be able to walk free. He'll spend no time in jail whatsoever. Finally, if both confess, then the police can actually punish them for robbery, and then that's going to result in a much greater jail sentence than trespassing. In this case, it's going to be 8 months in jail apiece instead of 1 had they only been able to charge them with trespassing. So the question looks like this. Suppose the thieves only want to minimize the number of months they spend in jail. We're making an assumption here. We're supposing that the criminals only care about themselves for the moment. If that's the case, should they confess to the police? Now, we saw a lot of information in the last 2 slides, but we can condense it into just this little payoff matrix right here. This is what we call a prisoner's dilemma. So we have 2 players, player 1 and player 2. Each of them has 2 strategies. They can either confess or they can keep quiet. And then based off of those strategies, you end up at different outcomes. So if both keep quiet, then they both spend 1 month in jail, so they both get -1 there. If one confesses and the other one keeps quiet, the one who confesses, in this case player 2, gets no time in jail, and player 1 gets 12 months in jail, so that's a -12. It's the reverse situation over here. And then finally, if both confess, then you end up over here, where they both spend 8 months in jail. And of course, if you get confused about the payoffs, you just notice that these are color coordinated, where player 1 is player 1 is blue rather, and player 2 is red. Now also in game theory, we have the following convention. We make player 1 a man and player 2 a woman. The reason that we do this is so we can use pronouns like he and she to differentiate between the players without creating any extra confusion. So that aside, let's actually solve this game. And the way we're going to do that is by noting how player 1 and player 2 should respond based off what the other person is going to do. So let's look at this for a second like this. This is just highlighting player 1's payoffs here. Suppose player 1 knew that player 2 was going to keep quiet. He could just predict this, and he saw into the future, and he knew that player 2 was going to keep quiet. What should he do? Well, if we look at the payoffs on the screen here, we see that he's better off confessing than he is keeping quiet, because he spends no time in jail if he confesses, and 1 month in jail if he keeps quiet. So 0 is greater than -1. He should confess if player 2 keeps quiet. Now suppose player 1 knew that player 2 was going to confess. Think about what he should do here. Well, if he keeps quiet, he'll spend 12 months in jail. If he confesses, he'll spend 8 months in jail. So in response to player 2 confessing, player 1 is also better off confessing. And if you string these 2 pieces of information together, whether player 2 keeps quiet or player 2 confesses, player 1 is always better confessing. Confessing always leads to a better outcome. And we say that player 1's confess strategy strictly dominates his keep quiet strategy. And so in general, strategy X dominates strategy Y if X generates a greater payoff for Y regardless of what the players do. So in this case, this is confess strictly dominating keep quiet. So keep quiet is strictly dominated. Now, rational players never play strictly dominated strategies like keeping quiet. The reason for that is, why would you want to keep quiet when you could confess and do better? And so in general, why would you want to play Y when you can play X instead? And so in the future, as we go through these videos, we're going to make sure that these players are never going to be playing strictly dominated strategies, because it just doesn't make sense for them to ever do that. And so to finish solving the prisoner's dilemma here, we know that player 1 is going to confess, so all that's left is to figure out what player 2 is going to do here. So imagine that player 2 knew that player 1 was going to keep quiet. We can see that she's in the exact same boat as player 1 is. If player 1 keeps quiet, she's also better off confessing because 0 is greater than -1. But on the other hand, if player 1 is going to confess and player 2 could see that in advance, again, player 2 would also want to confess because -8 is better than -12. And so you ended up starting out with 4 different outcomes possible here, but we know that there's only one sensible outcome, and that's for both players to confess. Now, when you first show this to people who are new to game theory, they'll ask you, wait, that doesn't make sense. Why did they end up in this outcome right here when this outcome, when they both keep quiet, is mutually better for them? And it's true, this is a better outcome for both the players collectively, right? Because -1 and -1 is better individually and collectively than confessing and ending up in 8 months in jail apiece. But the reason that this outcome isn't sensible is because each of them can individually do better by switching off to confess. And so there isn't a stable sort of solution here, because they can always do better by flipping their strategies and going to confess, even if they agreed to do this in the time before they actually went into the interrogation rooms. Those sorts of agreements don't actually withstand the test of time, because as soon as they get into the room and actually have to confess or keep quiet, it's in their individual interest to confess and not keep quiet. And so that's why we think that this is the only outcome that's sensible when both of the players confess. So that is the prisoner's dilemma and strict dominance in a nutshell. And in the next video, we will start talking about how we can use the strict dominance idea to get to even more complicated game solutions. Join me then.